Okay, so let's do the same for y is equal to 3 cosine of theta plus 4 sine of theta. And let's have the angles and also the values of 3 cosine theta and 4 sine theta. So that means that we have to adjust. Okay, so I need 4 more lines. 4 more lines, one for, now this is a little bit, lengthy and it consumes time. So we will just do one more example, which is 3 cosine theta plus 4 sine theta, just to introduce you to the combination of sinusoids. Now we have a constant at this point now. A while ago we don't have any constant, but at this case we will have a constant. So the first column will have the different values. We have theta, y1, y2, and the combination. So 3 cosine theta plus 4 sine theta. And let's select angles here. So we'll select 0 and then up to, this is only good for 1 revolution, I think. Okay. So right now I am creating divisions to accommodate the possible angles. So the first row, this time we're going to use the row. Okay, first row will be for theta. The second row will be for, let's call this y1, y2, and the combination as y3 or y, it could also be y3. So let's have y1 here, y2 and y3 on the last row. So if our theta, let's begin the theta from 0 and then going to 30 degrees, 45, 60, 90 degrees, 90 plus 30 is 120, okay, 135, 150, and then we have 180, and then we have 210, 225, and 240, 270. I think we're missing, so after 270 we will have 200 or 300. Okay, after 300 we will have 330, and we're missing 1 column, so let's just add a column. Okay. So let's add here 360 to complete 1 revolution or 1 cycle. Okay, and after that, so we have to find the values. 3 cosine of 0, that would be 3, right? Because cosine of 0 is 1. And 4 sine 0, it would be 0. So 3 cosine 30, that's 3 squared of 3 over 2. So that would be, well, let's just use the exact values. 3 times square root of 3 over 2. And 4 sine 30, that would be 4 times 1/2, so it would be 2. Okay, for 45 degrees, that would be 3 times square root of 2 over 2. And we have 2 square root of 2 over 2, or 4 square root of 2 over 2. So that would be 2 square root of 2. Okay? For 60, our cosine is 1/2. So that would be 3 over 2. And sine 60, that would be 4 times square root of 3 over 2, so 2 square root of 3. For 90 degrees, our cosine will be 0, and our sine will be 1, so we have 4 here. For 120, well, the reference angle here will be 60, so if 60 degrees, we will have to get this, and our y1 is cosine, so it would be negative 3 times 3 over 2, so that would be negative 3 over 2. For sine, that would be square root of 3 over 2, okay, so that would be positive 4 square root of 3 over 2, so that would be 2 square root of 3. For 135, that would be in the second quadrant where our sine is positive and our cosine is negative, so this would be 3 square root of 2 over 2, and this for the sine would be positive, so we have 2 square root of 2. For 150, the reference angle is 30 degrees, so we have to have this value. For cosine, we will have a negative value, so negative square root of 3 over 3, or negative 3 square root of 3 over 2, and for cosine it would be, or for sine rather, it would be 1/2, so 1/2 of 4 would be 2. For 180, well, we have 0 for the 0 for sine and negative 1 for cosine, so that would be negative 3 for cosine, and for sine that would be 0, so this is 0. For 210 degrees, well, at 210 degrees the reference angle is 30 degrees, so because the reference angle is 30 degrees, we have to look for 30 degrees value here, and both are in quadrant 3. So in quadrant 3 both are negative. So for 30 degrees that would be negative 3 square root of 3 over 2. The same is true for sine, we will have negative 2. 225, now all of these from 210 to 240 are in quadrant 3. So for 45, just get the values of 45 degrees here. So we have negative 3 square root of 2 over 2, and here we will have 2 square root of 2, that would be negative also. 240, so the reference angle is 60 degrees, that would be negative 3 over 2, and negative 2 square root of 3. And 270, this will be negative 1, for sine is negative 1, so this would be 0, and this would be negative 4. And for 300, that would be a reference angle of 60 degrees from the horizontal, and sine is negative here, so 60 degrees, find the 60 degrees values, and sine is negative, and cosine is positive, so that would be 3 over 2 for cosine. And what else? For 330 degrees, we have a reference angle of, or we're missing one here again. We have 315 degrees. So let's just put it somewhere. Okay. We missed 315 degrees here, so we're going to add another. Okay, this completes the one revolution. It's very lengthy to graph this combination of sinusoids. Okay, so this is 315 degrees, 330 degrees, and finally 360 degrees, so we're not missing anything anymore. Okay, 315 degrees, that would be 45 degrees, and our sine here is negative, so negative 2 square root of 2, and our cosine is positive because it's on the fourth quadrant, so 3 square root of 2 over 2. For 330, that would be 30 degrees reference angle, so 3 square root of 3 over 2, and then we have negative 2 for the sine function. Okay, So 360 degrees, we have for cosine we will have 3, and for sine we will have 0. So this completes the values of the parent functions, the y1 and y2 specifically. And now we will go to the combination. So if we add these two together, that would be 3. Now if we add these two together, that would be 3. 3 squared times 3, okay, equals divided by 2. That'd be 2.6, so approximately 2.6. And then we have 3 squared of 2. So 3 squared of 2 2 squared times 3 equals divided by 2 equals 2.12 plus 2 squared of 2. So 2 times 2 squared. So it's 4.9497. So it's approximately 5, let's say. Okay. Next we have 3 over 2, so that's 1.5. 3 squared times 2 equals plus 1.5. So that would be around 5 also. 5.0. Okay. Is it? Let's do it again. 1.5. 3 squared times 2 equals plus 1.5. It's 4.96. So 5. How about the other one? We have for the other one, because I think they're close, right? So 3 squared of 2 over 2, or 3 divided by 2 squared equals 2.12 plus 2 times 2 squared equals 4.949. The other one was 4.946. So they're similar. Okay, and this we have 4. And here we have negative 1.5 plus 2 squared of 3. So negative 1.5 so it will give you 1.696, 1.964, so like 2. Okay, and on the other hand we have 3 divided by square root of 2, so 2 times 2 squared equals minus 3 divided by 2 squared equals 0.707. Okay, next we will have negative 3 square root of 2, or negative 3, let's do that, square root of 3 squared times 3 equals divided by 2, that's equal to negative 2 point minus 2, so 0.5980, it's negative 0.5980, or 0.6, let's say. How could you jump to negative 0.6 if it doesn't have any 0? Okay. Okay, let's do this again. Three times, let's do this again because I'm not satisfied with this. So we have 3 times 2 square root equals, let's negate it, divided by 2 equals, that's negative 2 plus 2.121 plus 2 times 2 square root, that's 0.07, so we're correct. And this is negative 3. And then we will have negative 5 here, negative 5 also, and in here we will have this is 2.6. Okay. That's why should be 4.59, 4.6, not 2.6 here. That's why it's kind of odd. So this is negative 4.6. This is negative 5. This is negative 5 also. This is negative 4, of course. And then this would be 3 over 2, so 2.0, negative 2.0. And this is negative 0.7. And finally, we will have 3 square root of 3 over 2. That would be positive 0.6. Okay, now just to complete it, it would be 3 times 3 squared divided by 2 equals minus 2, okay, 0.6. So all in all, we have the right answers. And finally, this is 3. Okay. And so now we are ready to plot all the graphs, so the individual graphs. First let's start with y1, and y1 here is indicated in the blue, okay? So it's in blue. And to graph this is, remember, this is a cosine function. So because it's a cosine function, we will have a maximum point at 3, and we have a minimum point at negative 3. So this is a graph of the cosine function on 1 revolution. Okay? Now the cosine function, or the sine function, the y2 or 4 sine theta, is in red. So we're going to graph this, and take note that this is a sine function, so it will have its first maximum point at 4, and it will have an intercept here. Okay, let me try to make it smoother. So it will be like this. That's for the function 4 sine theta. So this is y2, this is y1. So y1 and y2. Now interestingly, our third function, which is the combination of the two sinusoids, is in green. So let's plot the function, and the graph formed by this sinusoidal function, which is the combination of the two graphs. So if we're going to combine the sinusoids, we will get an interesting curve that is like this. So notice that the points on the individual sinusoids are also taken, and they also define the what do you call this? A combined sinusoid. So let's make it smoother. should be smoothly like this. Okay, so this is our graph for the combined sinusoids. The point should be on this line, on this curved line. So because our sketch is not so accurate as to a graph, then we have missed some of the points there. But anyway, we have the same, or I mean, on the average, we are successful in conveying the sinusoidal graph. So this is the graph of the combined sinusoids. Call it Y3. So this is Y3. So take a look that it has a maximum at approximately 5 and a minimum at approximately -5. Okay, so comparing it to the graph on the book, so this is the graph on the book, and this is taken for 1 revolution also. And take note that we have similar graph. So this is how we graph a combined sinusoid. Okay?